Alright, number 1 on the final review packet. So you have a 2 kilogram object that's attracted to a 40 centimeter, or attached to, 40 centimeter rope swung in a horizontal circle at a constant speed. So the object is going to make 20 revolutions in 5 seconds. So the first thing we're supposed to find is the tangential speed. So tangential speed just means linear speed. So that variable is regular v, usually with a subscript of t for tangential. So there's a couple equations for that. Regular linear velocity is distance over time. When you spin something in a circle, you end up doing 2 pi r, which is the circumference, because you travel one full circle. And then capital T stands for period, and that's the time for one full revolution. So you end up with velocity equals 2 pi r divided by t, radius is r, and then capital T is the period. In this particular problem, you have a mass of 2 kilograms, as I already mentioned. The radius is 40 centimeters, and centimeters needs to always be in meters, so it's 0.4 meters. We know that it's going to make 20 revolutions in a total time of 5 seconds. At this point, we need to figure out what it is that's going to go into this equation. So we need 2 pi r and t. So the first thing you have to do is figure out what the period is. We know lowercase t is 5 seconds. So capital T is going to be total time divided by number of revolutions. That's going to give you the time it takes for one revolution. Total time of 5 divided by 20 is going to give you a period of 0.25 seconds. Now that period is going to get plugged into your velocity equation, where velocity is 2 pi r divided by period. So we do 2 pi times 0.4 and divide that by 0.25, and that ultimately is going to give you your answer of 10.05 meters per second. That's a little fast, but for this problem it makes sense because all the numbers work out. So 10.05 meters per second is the tangential velocity. The next part is the centripetal acceleration. Now, centripetal acceleration is the acceleration pulling it towards the center, and that has an equation of a subscript c equal to v squared divided by r. Okay, the v in that problem is going to be your tangential speed, r again is radius, and then a stands for the acceleration. We just calculated the velocity, so we can plug that right in. The radius we already knew from the problem of 0.4, so you do that math, you end up with a relatively high number, 252.66 meters per second squared. That number is outrageously high, but again, it still works with the problem. That direction of acceleration is going to be directed inward. Anytime you have a centripetal acceleration, it's trying to pull it towards the center. The last step is to find the tension in the rope. Now, force of tension comes from an object pulling out on this rope, which tightens it. So, as the object is spinning, we want to figure out what force is causing that. Anytime you're doing circles, centripetal force is usually a good bet. In this particular case, centripetal force is equal to the force of tension. So, mv squared divided by r, and v squared divided by r we already talked about as centripetal acceleration, so that's mass times acceleration, which is the formula for force. So you can do the mass of 2 multiplied by the acceleration that we found to get 505.32 newtons. So that's going to be the force of tension in the rope as this is swinging in a circle. And that's it.